Hello. We're going to do the laws of logarithms today. And these are 3 rules that we can use to do algebra on logarithms. And first of all, we have the product property. And I'll show you how this works. If you have 2 logs with the same base, as long as they have the same base, and you are adding them together, you can rewrite them as a single log of their product. Okay? The quotient property does subtraction. So if you have 2 separate logs, same base, they do have to have the same base, that are subtracted, you can rewrite that as the quotient of the different x values. And the last one, this is, I like to call them Law 1, Law 2, and Law 3, so I am going to label them that way. This one is really cool. It actually allows you to take an exponent that you have on the x value of the logarithm, and you can move it in front of the logarithm. This is super handy. But in general, I call this Law 1, I call this Law 2, and this one Law 3. So we'll come back later to why this works because we're a little short on time today. But what we're going to do is we're going to practice using these. So take a look right now at the laws, and because they're going to disappear off my page when I bring up the problems that we've got to work on here. All right. With these, let's see, can I get this, fit this in there? Yeah, we can kind of fit it in there. You'll see this looks like Law 2, right? I have 2 logs. They're both base 4. They are subtracted. I can write them as a single logarithm using a quotient. So here's what this is going to be. This equals log base 4 of 32 over 2, which equals log base 4 of 16. Fair enough? Not too bad. And then from there you can decide if you want to then figure out what that logarithm is, and we can do that by remembering our definition, which I'll write for you here again. Y equals log base b of x is the same thing as x equals b to the y power. Alright, so this is your b, this is your x value, and this equals your y value. So if you rewrite it in exponential form, this is going to be 16 equals 4 to the y power. Now, we need a common base here. I can write 16 as a power of 4. It's 4 squared. So I have 4 squared equals 4 to the y power. Now, if I have the same base on both sides, my 2 exponents must be equal, so y must equal 2, and I can go back up to here, and this actually will equal 2. Alright, if we go to example B, the very first thing that I'm going to want to do, I've got these numbers in front of my logarithms. I'm going to use Law 3, and I'm going to move those. Alright, so this is Law 3, this comes up here. This comes up here, and what I have is log base 2 of x to the 6 plus log base 2 of y to the 5th power. Now, if I squeeze this down the screen a little bit more, you can see Law 1 at the very, very top of the screen, and you can see if I have 2 logarithms with the same base, which I do, I can rewrite them as the product of the x to the 6th and the y to the 5th. So this equals log base 2 of x to the 6th, y to the 5th power. Alright, we're going to do the same thing in reverse here. We're going to do the same thing in reverse. So if you look at the very bottom of the page, that is the answer. I want to write this all expanded. So I have a single logarithm and I want to expand it. Okay? And so here's what I'm going to do. Take a look at Law 2. Would you agree? The left side of Law 2 is what we happen to have here. So this is going to equal log, what's my base? Because you don't see one, do you? It's 10, okay. So log 4x minus log y. All right? We can actually, believe it or not, we could even go further if we wanted to, because this is a product right here, and I could use law 1 and write this as 2 logarithms added together. So this would become log of 4 plus log x, then minus log y. So I've expanded it into very simple logs that are all separate. So let's go ahead and we're going to do that right here. So the first thing I'm going to do, use that law 2. That's the first thing. So this is going to be log base 9 of x to the 4th minus log base 9 of 729. Oh, I feel like that's got some stuff in store for us. Okay, next thing we're going to do, we can actually use law 3, and we can take this exponent and move it in front of our logarithm. This is with law 3. So this is 4 log base 9 of x minus log base 9 of 729. Now this has a variable in here. There's no way we can simplify this. However, we might be able to do something with this, so we should at least try. So again, this would be your b value, this would be your x value, and the y value is unknown to you at this time. So if I am rewriting this, this would be 729 equals 9 to the y power. Whoops, there we go. I wonder if 729 is a power of 9. So I'm just going to get my calculator out and give that one a go. How about 9 to the 3rd power? Oh, 9 to the 3rd power it is. That was just a guess, but I got lucky. All right, so this is 9 to the 3rd power equals 9 to the y power. And if you see, since we have the same base on both sides, the exponents are equal. And so this whole thing right here equals 3, because that's our y. So our final answer would look something like this. 4 log base 9 of x minus 3. Okay, let's turn the page. This actually brings up something that I talked about on the last video about your calculator. So I want to show you on your calculator. You have a logarithm key, and it's right here. And see how it has no base? This is log base 10 key. And you don't have, I can show you later how to use different bases, but let's assume that you can't use different bases because your calculator doesn't have those capabilities. It does, and I'll show you later. But there is a way that we can rearrange our logarithm to get the calculator to do it. And it's called a change of base formula. And so here's what you're going to do. I've got log base 81 of 27. Fair enough? All right? And I can't put log base 81 in my calculator. It's flat out not going to work because my calculator calculates base 10. All right. This has calculator base 81. What we can do is write a fraction here of 2 two different logarithms. So here's what we'll do. Log base, just watch and see. Log base 81 of 27 equals log, right, I want base 10, right? Base 10 of m, which is this thing right here, 27, divided by log base 10 of the b part, which is 81. So my 81 went down here, and my 27 went here, and they both have base 10. So now, in my calculator, I can do this. To calculate this out exactly, I can do this, parentheses, log 27 divided by log 81. And I get 0.75.
That's just the answer?
Mm-hmm. Okay, let's do this one. So remember, this goes on the left-hand side. So over here, we're going to write this as a fraction. We're going to have log base 10, right? Because that's what our calculator will do. And remember, the base goes to the bottom, the x value goes to the top. So log base 10 of 36 over log base 10 of 5. And now we just put that in our calculator. So we're going to do log 36 divided by, and notice I'm putting my logs in parentheses, and this is to make sure my calculator does everything the right way. Log base 5. And I get 2.2266. When you're giving a decimal approximation of a logarithm, you really want to give us 4 decimal places. That's probably your best bet.